Hi, I'm Paolo Cuomo and welcome to the City Quantum and AI Summit podcast series. I'm delighted today to be joined by Elitsa from NVIDIA. Elitsa, let's dive straight in. Please tell us about your background and how you got into the quantum and AI space.
Thanks, Paolo, for having me here. It's a real pleasure. My name is, as you said, Elica Kyoseva, and I'm Director of Quantum Algorithm Engineering at NVIDIA. My background is in quantum computing. I have a PhD in the field, and I started originally in academia, which is the usual background, I would say, for most people, still in quantum computing. The research that I did initially was in the field of quantum optics and quantum control, which has a lot of applications to control of quantum computers. And about 4 years ago, I started working on applications. So I started working more towards the top end of the quantum computing stack. And I was looking at particular at finding applications of quantum computing and algorithms to human health challenges. And I was a research scientist in a pharmaceutical company where I worked on quantum computing for drug discovery. After that, I launched a program called Quantum for Bio, whose mission is the development of algorithms for human health. And about half a year ago, I joined NVIDIA to lead the applications and algorithms engineers.
Perfect. Well, that's great. Now, NVIDIA, of course, is a business that we don't need to go very far back and no one had heard of them. And now it's, one of the planet's most valuable companies. So tell us a little bit about it as a company and what has driven this change.
NVIDIA invented the GPU, the graphics processing unit, about 25 years ago. And the difference between the GPU and the CPU, which is a general purpose computer, is that the GPU is very well suited for performing operations in parallel, many operations at the same time. Initially, it was recognized that the application of the GPU will be in graphics and in gaming. But very soon after that, some researchers started using GPUs for scientific computing. And this enabled a whole inflection point in scientific computing when scientists started using GPUs. Then there was another inflection point for deep learning when it was recognized that GPUs are very well suited also for deep learning. And in 2016, as well, people realized that they can use GPUs for artificial intelligence and for training large language models. And NVIDIA GPUs are the ones that supplied a small startup at the time called OpenAI with the hardware to train their transformer models. So NVIDIA has a very rich background spanning over 25 years of accelerating computing revolutions. And in terms of the next computing revolution, which will be the quantum computing revolution, this is exactly what we intend to do as well. We get engaged. We don't build quantum computers. We have no interest in building quantum hardware. There are many players that do that. But what we do is we supply the whole classical infrastructure. We build the software model as well, the programming model. And we believe that the future useful quantum computer will be actually an integrated quantum computer with classical supercomputers.
Excellent. That makes sense and certainly sort of fits what a lot of the discussions that we'll be hearing at the summit around that combination of quantum computers and classical ones. So thank you for that. The next question, I guess, around commercialization. Ultimately, the techie ones amongst us can get all excited about the tech for the sake of tech, but ultimately it only works if it can be commercialized. So sort of talk maybe a little bit about, where we are on the AI side, and then obviously quantum's a bit further behind on the commercialization side. You spoke already about human health, drug discovery, bio, etc. Where is the actual money being made that's commercializing these ideas?
The money are really in the problems that are very hard computational problems. When we look at AI and quantum computing, I would say for the moment they still have different ideas as targets and different use cases for targets. So AI, as we know from our daily lives, if we forget about the quantum computing aspect, it's really good when it has a lot of training data. Of course, this data has to actually also be of good quality, but in principle, we can say that AI needs a lot of data in order to be useful. The problem with quantum computing is that loading data on quantum computers, loading classical data on quantum computers is actually a very big challenge, and it's still unsolved. So that's why there is quite a consensus among the community that quantum computers will be useful for problems that are small data problems, that are after that exponentially hard, that grow, the complexity of the problem grows exponentially as we add more and more, let's say, parameters to it. So because of that, I still see the applications and the industries that are looking for the solutions from AI and quantum computing to be complementary to each other, and they are not overlapping.
That makes sense, and I like that explanation that it's a sort of small data, but a large number of parameters or a large number of combinations. So that makes sense. Thank you. This year will be the first year that you've attended the summit. Please tell us a little bit about what's drawn you to it. I'm sure you're invited all over the world for these type of events. Why are you coming to London in October?
Yeah, so thank you for the invitation. I'm really looking forward to it. For us, it's a strategic event because we see the developments around the world. So NVIDIA Quantum, of course, is operating around the world. And we do have a few strategic locations around the world that we try to keep very close contact with. And Europe, and in particular the UK, now that is not part of the EU, is definitely a place that we like to keep in touch. In the UK, we have a very broad history of quantum computing excellence and quantum computing research centers. Of course, we are very much aware with them, and also supercomputing centers like the Hartree Supercomputing Center. So because of that, for us, it's very good to engage with the European and in particular UK ecosystem. And also the other participants that you managed to invite and to gather are very high profile with a lot of diplomacy. So because of that, for us, it's a priority to be there in person.
Fantastic. Well, looking forward to it. If you had to think of sort of one key message that you're looking forward to sharing with the audience, what would that key point be?
My key point would be quantum computing and classical AI supercomputing are not in competition with each other. So what we should actually focus on is using classical AI supercomputing to enhance and to push forward and to enable the quantum computing revolution. And we can do that by enabling quantum computing research and discovery with AI supercomputing. And also we can do that for the running of the quantum computers once they exist, for their operation, for error correction, etc.
Perfect. That makes sense. So maybe then just to close, a final question. What are your professional hopes as clearly someone who's able to combine technology and commercialization and impact? What are your professional hopes for how this technology will help humanity and society over the next few years?
For that answer, I would go back to my background in human health, and my personal hope would be, and I'll be really happy if I see that quantum computers integrated with AI supercomputers can really push forward what is possible to do currently only with classical algorithms and with classical means for problems in human health. And there, the opportunity is still very, very large. There is such a large class of diseases such are not treated. They don't have any treatments. Drug discovery is a very expensive process. So for me, it would be great if we actually see application of quantum in that area.
Fantastic. Yes, that's definitely an aspiration we can all share. So, Elitsa, thank you for sharing your thoughts and thank you for joining us in October.
Thanks, Paolo. I'm looking forward to meeting you there in person.